Thank you very much. That was beautiful, Dylan. I laughed, I cried. It became a part of me. Okay. Okay, this is kind of exciting. It's been a while. How many people here write code for a living? Just making sure. Okay, how many people here are architects? Team leaders? What else is there? Testers? Security? Operations? DevOps? Something like that? We don't know what we are everything and nothing in the same thing? Okay, perfect. Next questions. I'm sorry about all this because I want to know who I'm talking to. How many people here work for an organization that is smaller in terms of amount of developers, smaller than 50 developers? Okay, that's not good. Smaller than 200 developers, smaller than let's say over 200. Okay, over 500, 1,000. Where do you work? Sorry? You just started. Is that what you said? I just market. Okay, I guess that's good. Where do you work?
Morgan Stanley.
Morgan Stanley, I've heard of them. I think they might be good someday. So the problems I'm going to be discussing today are problems that I've seen mostly larger organizations do. And what I think you can take from this if you work in a small organization is the anti-patterns before they start emerging, okay? Before things start to get really bad, we can still stop it, okay? That's what I'm gonna try to show you my point of view. Over the last, let's say, 7 years, I've been living and working in Norway and in the United States in some of the world's largest organizations and trying to achieve continuous delivery. And of course, some of these failed miserably. Some of these succeeded partially. Nothing is perfect, so it's all a journey. So all I can do is try to share the things that I've seen and what I think does make things successful. A little bit about me. I wrote The Art of Unit Testing. I'm actually rewriting it these days in JavaScript, so that's going to be fun. I wrote Elastic Leadership. This is also what the workshop will be later today. And I'm writing a book called Pipeline Driven, which is all about the topic of this talk. I'm also working as a consultant and trainer and coach. We moved with our family back to Israel a couple of years ago. And you can find all the information, everything that I'm talking about at the blog at pipelinedriven.org. So the key points I want to make today, I want to show you the idea of cooperative pipelines versus waterfall pipelines. It might sound a bit weird. I'll explain exactly what I mean. I'll talk about cross-stack skills and why that matters and why it's actually good for us to move into that direction. And of course, the elephant in the room, when everyone says the words continuous delivery, they think about these companies, these Netflixes, these Facebooks, these deliveries hundreds of times a day for our software. And these are all, they're usually, I can think of them like unicorns. These things, they don't really exist in real life unless you're part of this very, very small group of companies. And I wanted to explore why is that true? Why are these companies successful where a lot of other companies are not successful in achieving true continuous delivery? And from my experience, companies that try to implement pipelines and Jenkins jobs and all that stuff, they don't really achieve true continuous delivery. They achieve, let's say, intermittent delivery. I'll give you an example. When I work in multiple companies, we see something like this. And let me know if this makes sense to you. There's a dev pipeline. We do have a bunch of Jenkins jobs, and every time we commit code, it goes to a CI server, it runs a bunch of unit tests, and et cetera. And then if everything is okay, and I know this might not be true for some of you, but for some of you it is, then we have to move on to the next stage, which might be merging to a different branch, which might be moving on to a different department. So this is continuous integration in some way, but it's definitely not continuous delivery. Because in many companies, there is the next level, which is testing, or the testers or QA departments. And you might say maybe that's kind of an anti-pattern, but it does exist. And what I want to explain is that companies that try to implement continuous delivery and DevOps values and all that stuff, they try to implement it through multiple pipelines with people in the middle. So to move from here to here, there has to be a person in the middle that says, I think we're good to go. Someone has to approve or block or veto the decision to move on to the next testing phase. Is the pipeline okay? Are there a bunch of code reviews we need to do? And if so, sure, testing can take over, or we can deploy to the next environment where someone else does even more exhaustive testing. And of course, in many companies, that's not the end of the road. Maybe testers will then say, everything is okay, we are allowing you to move on to the next level in the pipeline, which is we'll let ops deploy to a specific staging environment or a bunch of other things that maybe compliance will not allow us to do. So there's another person here, right there, that has to approve. And what I've seen is it's a very kind of painful experience. You see, the company wants to go fast. And so the developers make a lot of changes, and then QA have to absorb all of these changes. And of course, a lot of times there aren't many automated tests, either unit tests or anything else. And even if they do, they take a very, very long time. They're very flaky. Sometimes a lot of the tests are failing. Has anyone ever had tests failing, even though they shouldn't fail? Okay. So what happens then? Then we have what's called, I call them build translators or build whisperers. You see, the VP of engineering will go to the QA, to the one QA person, the poor QA person whose job is to represent the quality, and that person has to then translate the status of that build, which seems to be red, but is it really red? So they ask, is it really red? Can we go? Because we really want to go to the next stage. And then the QA person has to gather all their guts and say, I think it's okay, not sure. And then that person has to take in all of that responsibility for hundreds and thousands of man-hours going into the development of all this, and then manually decide from all the reports that he or she sees, that everything is okay or not. Think about that painful type of responsibility. No one ever really knows. So then what happens? Either that person decides they want to keep their job and say, yeah, I think it's okay, or that person decides they want to risk their job and say, I will tell the truth that either I have no idea or I think it's actually not okay. And then the first few times, VP of engineering might say, you know what, I think that's good. We'll go back to developers, we'll tell them quality is not good enough. Developers will put in even more effort. Now what happens? VP of engineering comes into the QA and say, well, is it good now? Because we really got to go. We have a really important release coming in. Well, some of the tests are failing, some of the tests are passing. If we really want to know what's going on, it's going to take us a lot more time. If we're putting everything on me and I'm that QA person, you bet I'm going to do a bunch of manual stuff just in case, because it's my ass on the line. So all this stress comes in. And that person can veto, but it's a very long, arduous, and painful process. And of course, if ops takes over and moves on to the next stage, that's even more concerning. That's even scarier, right? Because ops want to say, everything is deployed, the environment is fully configured, and then they can move on. They can say deployment has been achieved. And in larger companies, a lot of times, because of security concerns, the people who do the deployment into specific environments and the people who write the code are completely different people. And so the people over here have to write instructions for the people over there to say, okay, this is how you install the application. There are usually no scripts available, and even if there are, the scripts that are there are different from the scripts that are here because of miscommunication between all of these departments. And so ops is now responsible to be the person that says the environment is okay, configuration is okay, rollback is allowed. We have to go back a version, we have to go to the next version, we'll change the version, we'll spin up a new environment. They'll have to build environments usually manually. It sucks. Then security comes in. How many people here in their companies have to deal with security issues at some point? How many people here have seen the faces of the security people? Okay, about 5% of the people who voted. Here's the problem with security. Just like there used to be a problem with ops, and there used to be a problem with testing, security is usually understaffed. And then, so even for large organizations, you're going to have a handful of people that have to approve or disapprove. So if you're working in an organization that wants to do continuous delivery, and to be able to do continuous delivery, you have to write scripts that deploy something, and that deployment requires maybe a bunch of open ports or something like that, or configuration to allow specific access, or you need a service user to be installed on machines to run the deployment process. The security people are usually very hard to find. They're full up to their ears in work, which means you might need to wait a week just to ask for permission to do something. There are usually change committees for security. The larger the organization, the more painful it becomes. And of course, there can be other things like compliance at some point. So is this a continuous delivery organization? And I would argue it has had nothing to do with continuous delivery. This is a waterfall pipeline. And the best way to know, I once consulted for a company, and I was working with one of the teams and said, well, do you work in an agile fashion? And they said, absolutely. First, we do agile, and then they do agile, and then they do and then we deliver. So we're all doing like agile development. And to me, this is how organizations try to translate the ideas of continuous delivery, and they just say, oh, I guess we need a bunch of Jenkins jobs all around that are automated, so we're definitely doing it. And it's kind of like the difference between saying, I do test-driven development because I write a bunch of tests. But it doesn't have to be that I write the test before. It completely misses the point of what it is to do continuous delivery. So if we have that kind of organization, this kind of process, it could take a very long time. Really what I've described here is a manual pipeline of pipelines. There are people in the middle to approve different steps. So if we look at the difference, organizations like the Netflixes and the Facebooks, they still have to do all these things. They might not have the exact categories of people, etc., but they still need to do the type of work that these things are doing, that these jobs are doing, and these people are doing. So they remove people from the process. That is the difference. It's a very simple difference, but of course it's not easy. So the difference between organizations like the Netflixes and organizations like a big bank is people do not make the decisions in the pipelines. That's the big difference. That's what I've seen, at least so far, is that to be able to enable continuous delivery, we have to let the pipeline make decisions that people usually make. What does that mean? So those people, all these departments and all these categories of expertise, they can be described as a single big pipeline, right? Where each one of them is responsible for a specific type of work. The only difference is that in large organizations, to deliver this single application, there are people in the middle of each one of these circles. And in continuous delivery, true continuous delivery, we don't have people in the circles. We have automated jobs that make decisions that people used to make. True continuous delivery means what types of decisions can we make? What types of decisions do we make at the pipeline that we used to make at a person level? And I call them tactical decisions, not strategic decisions, but tactical day-to-day decisions. For example, if usually a person is required to approve merging from one branch to another, or even have a separate branch, or to create a feature flag or to remove a feature flag, then the difference is that in a pipeline-driven, we have a special delegate, a special job that is coded, and that job defines a yes or a no whether the process should continue or stop. And if it continues, it means everything is okay, go ahead and do what you were going to do. So all of these decisions For example, moving to the next branch, moving to the next version, approving a release, approving a specific version of the application, checking performance, checking security, configuring environments. All of these are usually decisions that people have to make and approve and sign off on. But instead of asking a person if everything is okay, all I have to do is to ask the pipeline if everything is okay. It's really a big difference. It's not that the person looks at the pipeline and says, if this is green, then I tell you it's okay, and you can move on to the next phase. There is no person to say, that's green, you can move on. If it's green, it automatically moves to the next phase. So the pipeline automatically moves to the next state. The decisions are coded in the pipeline, and then the other categories, the expertise, the people, their job is to code those decisions into the pipeline. And I call these decisions delegates, pipeline delegates. And I'll explain why I call them that in a second. But one of the best things about this is once you try to implement these things, is you reduce the amount of stress considerably. Because if in the old world, I was in meetings and someone would say to the QA person, well, is the release okay? That person would have to sign off on something, sometimes with their blood, sometimes with their soul, their firstborn, whatever. I've seen organizations literally making people sign a document that says, this release is okay. Can you imagine how much your hand would shake if you're signing a document that says the release is okay? That's craziness. But what if instead of that, I could just say, you don't have to ask me. If the build is green, then the release is okay. That's all. And if the build is red, the release is not okay. That's all. And that way, I don't have to be stressed about the release not being okay. As long as the pipeline is red, we have to get the pipeline to green. That's what it means. And it's our job to write the pipeline in a way that we can trust it so that when it's green, it can actually deliver. This is where the next phase of this talk is. Pipeline delegates. So why do I call them pipeline delegates? You see, in a pipeline, I call this the cooperative pipeline. Before we had a waterfall pipeline, a cooperative pipeline is a pipeline where each one of the expertise in the company, and I'm just giving a few of these, you could have more expertise, for example, documentation, UX, something like that, whatever makes sense for you, are trying to code the decisions they would have made as people into an automated pipeline. And those decisions are coded as types of tests or scripts. And those tests or scripts are either failing or passing. So now my job as security is to say, look, I am not in charge of the pipeline, but I have a delegate. I have a representative in the pipeline that does my job for me. It's kind of like the UN. Okay, I also call this syndicate. I'm not sure what the right word for it. A syndicate, not a crime syndicate, but a syndicate. A bunch of people working together for a specific cause. So what happens in stuff like the UN? States have delegates. Delegates can vote. They can veto specific decisions, and this is what we care about. So if there are no major objections, the process can go on. What if we treat the pipelines in the same way? Because in a cooperative, we have work together as a team, officially authorized to undertake a duty or negotiate. So if I say, as security, I'm writing a piece of code and I'm allowed to veto the pipeline, I'm allowed to break the pipeline and make it red. It means that I code all of these things in a way that can run automatically. So if there's something I used to do that is that I would do some kind of port scanning. Usually security would have their own tool for port scanning, and it's automated, and they have command lines for it. What if I wrote a script that can be run from the main delivery build, and that script is either failing or passing? And if it's passing, security is basically telling me, we're good, bro. If this is green, we're good. Now that sounds kind of scary, and I realize that, but let's explore that for a second. How do you veto? How do jobs veto things in the continuous delivery world? Does anyone know? How can you fail a build? Physically, how do you fail a build? Does anyone know? throw exception, sorry?
Remove semicolon.
Semicolon?
Yeah. The compilation failed.
Compilation issues, okay. These are all implementation details, but what is it that the continuous delivery cycle is actually looking for to fail, do you know? Exit code, exactly. Exit code. Exit code is how we fail a build. So my veto depends on the exit status of my process. That's all. So if I want to write a script and I want that script to pass, I return 0. If I return anything that's non-zero, any CI server out there agrees with me that any non-zero means failure. Okay? So if we write tests, scripts, processes, anything like that, it doesn't matter what we use. As long as the process returns a non-zero result, it basically can veto the delivery process. Okay? This is a common, this is a standard way. So if you've ever wondered how things are failing and why they're failing, when tests are throwing exceptions, what's really happening? The test process itself changes the exit status to non-zero. You can have multiple exit statuses, multiple different types, but 0 means success, basically universally. Okay, so we know how to fail the build. We know how to pass the build, but do we trust the build? Do we trust the pipeline? Because if I go to a company, and this has happened, okay, when I consult for companies, and they are in situations where people are doing the major decisions, the tactical decisions, day-to-day decisions, that are stopping the delivery process. And I say, instead of asking that person, ask the pipeline, people become pale. They look at me and they say, yeah, no, that's probably not going to happen because we don't trust our pipelines. You want me, for that pipeline, if it's green, to basically, it means that the application is delivery ready. And I say, yes, that's what we want to do. And that person says, no way, because my pipeline it's in its infancy. It basically does very simple things. It doesn't know how to judge things correctly. That's why I have people that are translating the results of the pipeline, because the pipeline doesn't know what it's doing. The jobs in the pipeline, the tests are not good enough. We are missing a bunch of tests in different scenarios. And so it makes sense that we don't trust the pipeline, so we put people in the middle. So I would argue that assuming that we want to achieve true continuous delivery, then our delivery process, the software life cycle that we use changes, SDLC 2.0. It means that instead of just working on functional, we also collaborate to create pipelines that we trust. So if we want true continuous delivery, part of our job has to be maintaining and creating things in the pipeline, creating those delegates that we trust. And as long as we don't have delegates that we trust, we're going to have people in the middle. It will never change until we put things in the pipeline that we trust enough so if they're red, we actually stop, and if they're green, we continue without asking for permission from people. And of course, you can do it partially. You can say, well, up until this environment, we can go completely automatically up until a specific environment. And then one day, you might create the perfect job, the perfect delegate that says, if this is green, we can even go to that environment. And this could include writing feature flags and running tests with feature flags on and off. So we'll know exactly what would happen if we turn the feature flags in a specific environment. It could mean a bunch of different things. Every organization has a different pattern for what their delegates might look like. So if I look at these types of expertise, and I say, okay, if our main job is to, other than functionally adding to the product, if we want to achieve continuous delivery, we also have to treat the pipeline as its own application, as its own living, breathing thing, then we need new skills as well. If we are organized around the pipeline, and that's why I call it a pipeline-driven team or organization, where the pipeline actually makes the decisions and not people, then the people have to teach the pipeline how to make decisions. And this is what I think and what I believe organizations such as the Netflixes and Facebooks, that's what they've done. That's basically all they've done, is they taught and they trust their pipelines enough to remove people from the equation. What types of skills do we need as developers? Well, one of the main skills is, of course, to understand how pipelines work. And this is actually pretty scary. If I talk to an organization and we start asking people to get out of their comfort zone and learn new skills, you might come across a varied set of responses. Some people might say, this is awesome, I want to learn new things, and so I will do it. Some people might say, screw you, I'm here to do one job, and I'm good at that job. And now you're taking my time, and you're making me do things that no one has ever asked me to do. For example, you want me to start working on pipelines. That's what we have operations teams for, right? What about working in a feature team so I have to work not just on iOS, if that's my expertise, I also need to work on the back end. Screw you, that's not my job. I know one thing and I know one thing well. And eventually this thing can be repeated. If we notice this pattern, this is a very problematic pattern because this is where the make or break thing happens. If people are unwilling to learn those new skills, they will be unable to contribute to the pipeline. And if they're unable to contribute to the pipeline, we are creating those knowledge silos. So I guess what I'm saying is that knowledge silos create that organization, create that missing pieces, and so each expertise is now responsible of creating something instead of everyone being involved. I'm not saying that developers have to write all of the security tests or performance tests. What I'm saying is that whatever they do write has to run in a pipeline. It has to be something that they trust. They do need to understand security in some way because there are some things that security tests can only test at a specific level, but secure unit tests can test in a much better way. Or even just secure coding practices and adding security linting into the build process. If we think about security linting, that's also an example of a delegate, right? Any type of tool that can break the build is a delegate. But it's not just about that. A lot of developers are not comfortable with writing automated tests. They believe it's someone else's job, but it's not true. If we want to have people removed from the equation, we have to write automated tests because that's how the pipeline makes a decision. Same thing for infrastructure. If I want to be able to write tests and to run those tests automatically, I also have to understand how the infrastructure works. Maybe not everything, but at least some of it. Because part of the work that I'll do is about changing things like the Jenkins file and understanding where things will run. It will require me to elevate my skills. And that's a tough position to be in. Because a lot of developers today are very much in their comfort zone and they're good at doing one specific thing. But I argue that this will not be good enough in the next 5 years. As organizations realize more and more that they're not achieving continuous delivery, they're just achieving more pipelines, but the waterfall still remains. The handovers between people still remain. But developers are not the only ones who are going to suffer. Operations are suffering too. And if you are in operations, notice I'm not saying DevOps people, because that doesn't exist. We have people with expertise in operations. DevOps or DevSecOps or DevTestOps really, to me, is when we're missing the right words to explain what a pipeline-driven organization is. What is DevOps? It means that operations are using pipelines, just like developers, and they're using, of course, source code and all that stuff. What is DevSecOps? It means security is using pipelines, and they're doing things automatically, just like developers are, et cetera, et cetera, et cetera. So to me, this is what I call pipeline-driven. So I don't like these DevSecOps, because there's always going to be, what about compliance? Is it DevCompOps now? How many of these variations do we need until we realize that the pattern that underlies it is the pipeline? And this is the thing that changes. So what do operations people have to learn? And usually operations people come from two different backgrounds. Either it's previously developers who really love infrastructure, and then they're going to be all into this stuff, or it's previously pure IT operations, integration, configuration, integration folks that are there and they know how to manually do a lot of stuff. They work with golden images, and they have this kind of huge background in working in a way that is very waterfall-driven and manual-driven. And these people are going to have to learn a bunch of stuff that they've never done before, working with infrastructure as code and how to automate and writing infrastructure tests and understanding coding as a first principle. Basic coding, but still coding. They will also have to coach other people. Who will they have to coach? The developers, the testers, because everyone is going to need to know how to work with pipelines, right? But in traditional organizations, you need to work with Jenkins. Oh, talk to Jerry. That's in a different room, a different building, a different state, different whatever. But in this pipeline-driven world, everyone needs to work with a pipeline, so coaching is a huge skill that's required. Who's going to teach them coding? Developers. So developers also need to do coaching. And this maybe starts to give you a notion of why it's so difficult to implement continuous delivery in organizations today, because we're asking, and again, the problem is never code. We're asking people to change their behavior. It's always about people. If I'm asking for someone who's done something in the same way for 20 years to do something completely different, and not only that, to give up their power in some way and say, now everyone should be able to do what you do, and you should become more of a coach and teach people, and you can focus on more things later, but you have to now share this knowledge, that could be very, very scary. So no wonder a lot of times IT folks and operations or a newly minted DevOps folks are just the same thing with just a different name, because they don't realize that the skills that they require are not just about creating a new Jenkins pipeline. The skills are completely different from that. They have to coach other people as well. They have to learn about connecting multiple pipelines together into a single one. Security. Security, I think, today is still in its infancy in understanding how to fit into the continuous delivery landscape. Security today is still a very much kind of go to the top of that hill. There will be a person there with a white beard, and that person will tell you if you're allowed to do something or not. You will not understand why. Maybe the only way they will talk to you is through fax. I don't know, I'm just kidding. But a dove will come in and give you a note that says, you may open this port on the firewall on the third day of the third year, et cetera, et cetera. Nobody knows why. But what if I could understand their brain? What if I could have access to the person in security and say, why is it that I'm not allowed? Well, I mean, I want to understand. Maybe if I did understand, I would write better code. I could reuse some of the things. Maybe I would care more about it so that no one would have to bother me and say, you're actually doing SQL injection. What is SQL injection? Maybe nobody ever taught me. I'm using the most basic thing here, but if we don't talk to each other, then we've already lost. It's never going to come up as part of a pipeline. And here's the thing, security already have their own pipeline. They already have a bunch of automated tools. They do some stuff manually, but security, if you look at the OWASP community and stuff, there's a bunch of automated tools. In fact, if you look at what hackers do all day, they use automated tools. There are a bunch of automated tools for a bunch of scripts for everything. It's stupid not to use them in our pipelines. They also have to do coaching. They also have to teach other people. They also have to learn how to code if they've never coded before, or maybe they know how to code or write secure code, but they've never written security tests, actual tests that test something, maybe infrastructure tests and test specific configurations, like inspec, etc. Which there are different tools for this stuff. Testers. Testers, I think today, what we're noticing, and let me know if you think differently, that I see testers today as the category of expertise that is the most in transition towards that new world, okay? These are the people that are today kind of have the most painful experience in moving from the old world to the new world. So in many organizations, the questions arise, why do we even need manual testing or testers or the test expertise? Just let the developers do everything. Or they suffer the most in terms of signing off on things that they don't actually control. They might get a lack of trust because a bunch of automated tests have already proven what they're trying to prove manually. They might not have coding knowledge, but people are expecting them to start coding and start moving in towards that area. And so there's a lot of pain in that community. And here's the thing. the community of testers, assuming that you have people that know how to test well, and there are a lot of those with good experience, those people bring tremendous value to the teams. I don't think we should get rid of testers. I think that developers without the knowledge of a tester, thinking at the higher level, at the meta level, at the adversarial level, developers without that knowledge are not as good as they could be. So what I want us to do is to think about a world where, what if we could use the expertise of someone with the testing that has done this for a long time, and then put that mind into the body of someone who knows how to code and work with the pipeline, etc. But it doesn't have to be a developer. It could be a tester that also codes, and that tester can work on test infrastructure, of course, working inside part of the pipeline, and doing coaching. Because one of the nice things about pipelines is that in a pipeline, everything is a test, right? So if I'm a tester, I now have a superpower, because half of the organization doesn't know how to test things. They know how to write scripts, maybe, they know how to do specific, but they don't know how to think about testing the way that I do, the way that I've been doing it for a long time. They don't know how to think about the specific scenarios. They don't know how to look at something and say, what if we also did something like this, and it would cut open a specific world of knowledge? So testers, the way they are today, will probably not be available in the next 5 years, will be less and less available because they are already being required to work in a pipeline-driven fashion in some way. The difference is that they're usually required to work on their own pipeline instead of a cooperative pipeline. They work in a waterfall pipeline. So they have some automation, but there are still people in the middle of the process. So in terms of SDLC 2.0, the way I envision it, the way I see it, is that the organization is centered around a delivery pipeline. Not multiple pipelines, it could be, but eventually it is a single pipeline that underneath could have sub-pipelines, whatever, but it's fully automated, full of delegates inside of it, and these delegates are contributed to by all of these different expertise. And so a lot of the work, I would say 20, 30, maybe even 50% at the beginning, goes into, for any new functionality, to add veto power to make sure that we didn't break anything, to maintain those delegates. And the more time we spend on maintaining this, the better our pipeline will be, the faster we will be, because we have removed people from the tactical day-to-day operations. These are the skills that I see required. So I've put kind of the colors. So green means knowledge about coding, red means knowledge about security, purple is knowledge about operations. And you can see that each one of these categories requires a bunch of different knowledge. If we know this, we can plan for this. We can create a learning plan for teams and create a pilot team. And in this pilot team, we make sure that people learn and work on this knowledge. It means at the beginning, just like anything we're learning, things are going to be slower. They're going to be slower because we're trying to become faster, just like anything when we're learning new skills. It requires also some amount of being uncomfortable. So if we're going towards this route, we should plan for the point where the people around us are uncomfortable. They're used to working in a specific way, specific room, specific location, with specific people. And a very simple example of something that happens a lot is people are unwilling to relocate from their room and sit together as a different team. So operations people are sitting together, and now I'll ask one of them to sit with a development team because they're part of the team now and they're supposed to coach and work. Some people will be okay with it, but a lot of people are really not okay with it. They're afraid. They're afraid of losing knowledge from all of the other operations folks they're sitting together with today. Same thing with testers, same thing with if you ask security. I'm not even talking about compliance yet, okay? That's kind of a Mars versus the moon in a way. But compliance will have to be there as well. So this is, I'm not saying it's easy, but I'm saying if we want to compare ourselves to the Netflixes of the world, they've already done this. They already have this in place. That's why it works. They already have delegates inside the pipeline. They don't call them delegates. I call them delegates because that's my word for it. They already have a bunch of jobs automatically deciding whether a pipeline should fail. And every time they don't trust the pipeline enough to fail when it should, they just change the pipeline. They change the automated jobs. So everyone's role in these organizations is partly not just new functionality, but also maintaining the pipeline. That is the lifeblood of the organization. If the pipeline is green, we can deliver. If the pipeline is red, we cannot deliver. Okay? The question then becomes, what's in it for me? If I try to show this slide to people in the organization, there could be a lot of fear. But I will argue that it's actually good for us. I will argue that it's actually a better way for us to work. So for developers, why as a developer is it good for me to work in a pipeline-driven organization? Well, first of all, less stress. Less stress means I don't have to manually test things. I don't have to worry about whether something is truly okay if I trust the tests enough. This is why I always advocate for us to create trustworthy tests. Job security. You like job security, right? I call it cross-stack. I believe that that's going to be a required skill. People today say they say full stack. Full stack means application stack. Cross-stack to me means not just application, but also security and also pipelines. Okay? So these parallel types of thinking and testing. So if you are a well-rounded developer, it means that you know all of these things in some way. Now today that's considered kind of maybe a unicorn, that there aren't many people that try to work this way, that they know a bunch of these different skills. But I think that to achieve true continuous delivery, you have to grow people more and more towards that. Professionalism. If I have a team member and I say, look, I believe that true professionalism comes not just from understanding and living in a bubble, but by understanding all the people around you and the pain that they suffer, and what happens when you commit code. Where does that code go? In many organizations, if I ask, where does the code go when you commit it? People say, I have no idea. Or they'll say, it goes to this department, and from there, it is a black hole. And I think that this is an anti-pattern. I think that as the first time you go to an organization and you're joining a team, even if you're working in a bubble, it's our responsibility to understand what is this pipeline that we live in today? What happens when I commit code? What is the value stream that happens? What kind of meeting, which environment does that code go? Oh, nobody knows? Okay, maybe I'll go ask someone else. Now, if you're an organization where people are discouraging you from asking, now that's a different anti-pattern, I would say. Maybe it's time to consider either explaining why this is important or consider a different organization that allows you to ask the questions. And I've worked in both types of organizations. The organizations that succeed in changing things are the ones that allow asking sometimes weird or even stupid questions. It sounds like a stupid question when you say, so after this, do we actually deliver? And of course, I know that we don't actually deliver after we committed this stuff. But it forces people to answer, no, of course not. What, are you crazy? No, it goes to this, and then it waits for 3 months until, and if you work in SAFe, you've experienced this. No, we have when do we write the feature flags? Oh, we wait for the innovation sprint, if you've ever, and that's going to be a quarter away. And so you have to understand the process that you work in today to understand what it is that needs to change. It doesn't have to be just high-level managers. Stop waiting. If we are working in a pipeline-driven organization, one of the nicest things about it is that you don't have to wait for permission from anyone to add new functionality or to allow you to move to a specific state. The pipeline already takes care of that. You've removed most of the obstacles, the human obstacles, and so the only thing that's left is to pass all of the delegates. And of course, we can add more delegates because everything is in source control. Everyone has access to the source control. We have pull requests and code reviews, so it's okay to put things into source control. But if I need to open Here's an example. If I need to open a firewall port, in a pipeline-driven organization, that could look like I'm changing an infrastructure configuration. I'm writing an integration test that proves that I can something can talk to, let's say, my new microservice in some way, and then I commit that stuff. Now, I could also write a test that proves that a firewall port is open or not open. It will actually create the infrastructure configuration, load the new environment into a temporary environment where that configuration is actually true, which means if today I have one environment alive, and now I want to have open a port in there, I don't actually change this environment. I create infrastructure as code scripts. The pipeline will automatically load a new environment where this port is open and then run all the tests, including security tests and everything else. And if everything is still okay, then the change has already been done. Because the change of the firewall is in the infrastructure definitions. It is not somewhere in a specific location. It is all infrastructure as code. So I don't have to wait for permission as long as I don't break any of the other delegates. Someone might have a delegate, security might have put a delegate that says, no ports other than this range are allowed to be open. So if there is a port other than this range, then veto the build. And then my build will fail, and I'll see the error result, and I'll either change the port, or I'll go and discuss with security, why is that true? But there's a difference between that and actually changing things and getting the feedback instead of asking for permission and then getting a true-false and not understanding why. Because delegates, what's nice about them, they're code. You can see the code, you can see the rules. They'll usually have good explanations. They'll have links of why something is true or not true. So it gives us a much better explanation of what is allowed or not allowed, and then I can immediately change the way I work and work inside the confines of what the delegate allows. Security delegate. What's in it for the tester? Well, as I said, pipelines are basically a bunch of tests that either fail or pass, right? They return 0 or non-zero. Job security. If everyone has to learn how to work with pipelines, it means everyone has to learn how to write tests in some way. A script can also be a test. Everyone has to learn how to return a failed exit status code, how to test something, how to maybe even assert in their specific way, how to make sure that it makes sense, how to put it in a test suite, how to connect it to everything. Job security. Everyone's going to need my help. I can be a coach. We can focus on better, more interesting things if everyone is writing tests. Because now I can not only coach people, I can think about higher level tests. I can think about higher level delegates and say, okay, these are all good and fine, but there's a bunch of stuff that I think should be there. I can write a bunch of tests for it. I can make sure that the things that are important to me are there. I can teach other people how to write those tests as well. But it's all kind of a uniform way. We just code it into the problem. And professionalism. If I tell testers, look, in the new world, if I expect you to be a professional tester, which means not only are you doing manual, you have to learn how to do automated testing and code that stuff. A lot of testers have to grow up to be that, in that they don't have the skills for it. They might have a lot of other different skills, but this is part of the professionalism plan. So I can then put it on my resume and say, I am a well-rounded tester, I know all of these things. I don't just create test plans. In fact, all my test plans are automated, and I know all of these things. If I look at a resume of two different testers, one with all of these skills and one without, it's very easy to choose between them. Operations. Notice that I always put less stress at the top, right? Because each one of these expertise has to sign off at some point. And I hate sign-offs. I just hate them. Because every time you ask someone to sign off, you're going to get a small lie. You are, because no one ever knows. Unless you are working alone, you will never know all the changes that have been made. You will never trust that you've done all of the things that you thought of without the other person thinking of all the other scenarios. So it's always a leap of faith. Same thing for a pipeline. The only difference is a pipeline just removes the necessity of me, giving my firstborn if something is not okay. If it's not okay, hey, it's not me, the pipeline is red, what do you want? Right? or the pipeline is green and we had a problem, we know exactly what we need to do now. We have to add more delegates more tests to the pipeline so that it will not happen again. It's no longer about people writing that are doing manual tests. It's more about people adding things that they trust into the pipeline. So the cycle becomes better. Job security. Ops becomes DevOps. That's kind of a job security today. But if I look today at organizations that are transforming and I say, well, I have two types of ops people in the organization today. I have the ones that are sitting alone in a room and they're just doing all these crazy charts and nobody really knows what they're doing and they always go like this and yeah, we need to do this and the Docker and the Kubernetes and all the developers are like, what is he, I don't, what? And then there are others and I see them and they're sitting with people and say, okay, why don't we do this together? Why don't I teach you how to do something? Or let me add a bunch of tests as well. Let's do things together. Which type would I want to hire? Which type would I want to keep the next time I have, a refreshment of the troops, let's say? Which ones have a higher value for the other teams? And the difference is they all bring value, but the other type brings exponential value. Because not only do they do something, they teach other people how to do that something. So those other people don't need them later for that specific decision, so it's a force multiplier. The teams that work with those people become better teams. They become faster because they learn new skills. Security. I think we all know a lot of the problems with security. So it's not just what's in it for the organization, what's in it for the security person, because today security has a lot of job security, no pun intended. Security usually is a very thankless job. Nobody understands why you made your decisions. Everybody kind of hates you a little bit because they don't understand what it is you're saying. Or they don't even hear from you, you don't get invited to company parties, or I don't know. But the point is, you're separate. We want to feel part of something. We want to know that what we do actually matters and brings real value. In many organizations, security is seen as not bringing a lot of value, but something brought in from management. But as a developer, I don't understand the value of it because all I get is hundreds of errors that might not even make sense for my situation. And so what happens is that if security is part of the process, a part of creating the delegates, they will create delegates that make sense for the situation. And if I understand how to create security delegates, I can also create more like that. I'm going to be much more involved. So as a security, first of all, I have less stress, because if there's something more stressful than QA signing off on a release, it's security signing off on a release. Do we agree? So now, how much would my hand shake more by signing off on a release as a security person? And the answer is, I don't want to be shaking. All I want to do is I want to say a high probability of success, because that's all I can ever hope to achieve. So I'm going to put the most of what I know into automated tests. There are some things that still cannot be automated, but the amount of those things is so small, it's negligible compared to the value we can get from all the other things that can be automated in this security world. So as security, I can remove a lot of my stress and repetitiveness of my work by putting things in pipelines. My job security becomes better because people know who I am, and they know that that person is easy to work with and nicer to work with than the person I've never seen before but always tells me no. This person tells me no, but I understand why. There's a difference. Be more efficient and fast. Of course, I can be faster, professionalism, grow new skills. This is kind of the same thing. So with that, so just to summarize, so we have cooperative pipelines. I think that is the true enabler of continuous delivery. Not regular waterfall pipelines, but cooperative pipelines that require those different skills to achieve. And those different skills are harder to achieve because they require us to get out of our comfort zone, just like everything in software. Welcome to software, right? It's not just learning a new framework, it's learning a set of skills of working with other people. And those other people might not be crazy about the fact that they have to work together with you, so the first couple of months are going to be more difficult, but it will filter out the ones who are ready for this change than the ones who are not ready for this change. So it's really up to the company. Do you want to do true continuous delivery or not? If you do, I think this is the cost. I think this is what it takes. This is the difference between traditional and let's say modern continuous delivery. And at the end of the day, I think it's good for us as a community to learn all those skills, become better, and understand our job much better than to live in a bubble and not understand what happens once we finish. Thank you very much. If you want to find out more, you can go to the pipelinedriven.org to read the blog, 5whys.com for all of the leadership stuff. I believe without leadership, that stuff doesn't work. Working with people and getting them to change, again, it's all about people. You can find me on Twitter. You can ping me by email. Thank you very much, everybody, and have a great day. I'll see you soon. Thank you. Do we have 5 minutes? Actually, we have 5 minutes for Q&A if anyone wants to ask a question. Yes?
Because, hello? There we go. Awesome that we can have, a unified pipeline between all the different departments, etc. We take out the man in the middle. But the business is still going to want to have someone signing in blood saying it's all right, so they can come back to them and say, you've screwed up. Would you change the culture to be less about that, or how would you introduce a human into that cycle?
So are you saying that even though we have a fully automated pipeline, we still want someone on the outside?
Someone that is responsible.
That is responsible.
Yeah.
So I think this is human nature. We still need someone to blame when the pipeline fails. I think there shouldn't be a single person to blame because it's a cooperative pipeline. So we all contribute to it. We can find the source of an issue, right? So I'll give you an example from standard development practices, okay? Let's say it's not a different categories, just different teams working on different components in a single system. What happens if my component works perfectly and the other team's component works perfectly in a pipeline? But there is a system integration pipeline, and that system integration pipeline is failing. Should there be one person responsible when that pipeline is failing? And the answer is, of course, no. What there should be is a team of people, which is one from each group, from each component team, let's say, which I disagree with the idea, but let's say that that's usually what happens. But a team of people who know the different components and the different systems, and that team can change every week. And whenever that type of pipeline fails, that team is responsible for understanding why it failed and forwarding the issue to the relevant department or the relevant team. Same thing here. Because really this is just an integration of people and their skills instead of components or layers. So when a cooperative pipeline fails, you need a team of first responders, and it's not a blame team, it is a forwarding team. So someone, instead of everyone stopping, someone, maybe one or two people, stops, looks at the error, forwards it to the right team, which is responsible for those delegates that have failed, to try to understand if there's an issue, and then that team is responsible for either fixing the delegates or to contact the team that has broken the delegate to explain what's broken to fix it. That's kind of the idea, because they're the ones who are with the expertise. In a perfect world, everyone understands all the delegates. It's not a perfect world. That make sense? Any other, I think one more question, if anyone has one. Yeah. The person who half raised their hand, yes.
Sorry, thanks for the talk. I know you mentioned specifically that you haven't mentioned compliance in the pipeline, but how do you envisage it working within the pipeline? Just briefly.
Great question. Compliance. So I'll give you a story about real compliance. So I used to work for a bunch of large companies, and a couple of them had compliance issues in terms of compliance challenges in continuous delivery. So here's where compliance is actually easier than most people think. Because when I talk to compliance people, and we have kind of this C-level meetings, compliance will usually say, well, in order to be compliant, we have to prove that all of these examinations have been done, that all of these documents have been approved, that it really changes. All of these reviews have been checked off, And if that's all true, that's usually what I do as a compliance officer personally. I just go and I look at, let's say, SharePoint or whatever, and I look at all these documents, and I look for the signatures, and I look for the checkboxes, and I look at the logs, and I look at the test results. This is really usually what compliance becomes. It is a bunch of checklists. And the nice thing about checklists and documents and all that stuff, especially in a continuous delivery and pipelines have full records of everything that happened. So technically, you can create a compliance delegate in your pipeline that checks the logs of specific tests and checks that specific documents exist in folders or whatever and looks for specific checkboxes automatically. You don't have to have a person for that. The only thing you need to do then is to say to compliance, so if this script is passing and prove that all of these things are true and you can see the log for it whenever you want, is that okay with you? And if the compliance person for that specific day says, yeah, I'm okay with it, then you have a delegate. You have an automated delegate that checks all of these specific things. It really does come down to very simple stuff. Compliance is usually very manual, document-centric thing. We can automate it because the outputs from pipelines are fully automated log files, usually. So it's actually easier to prove that something is compliant than manually. So there are ways, but this is just like one small example of that. If you want, we can talk about it later. Okay, thank you very much, everybody. I'll see you soon at the workshop. Thank you.